Hello there, and welcome to The Sleepy Scholar. Tonight's journey takes us into the deepest reaches of the cosmic ocean, to the mysterious and boundless world of exoplanets. For centuries, humanity looked up at the glittering tapestry of the night sky and wondered if our home was unique, a solitary oasis of life and rock drifting in an infinite void. We saw the stars as distant, lonely fires, burning in the cold silence of space. But as our eyes grew sharper and our curiosity reached further, we discovered a profound truth that changed our place in the universe forever. Those distant points of light are not lonely at all. They are parents to their own families of worlds, planets that orbit far-off suns, each one a unique marble in the grand design of the cosmos. These worlds, known as exoplanets, range from gas giants far larger than Jupiter to rocky spheres that might strangely resemble our own Earth. They exist in bewildering variety, places where rain might fall as molten iron, or where two suns rise over strange horizons. Tonight, we will drift past these silent sentinels, exploring the sheer scale and magnificent diversity of the planets that share our galaxy, hidden just beyond the reach of the naked eye, waiting patiently in the dark for us to find them. If you enjoy these quiet explorations, I invite you to like, subscribe, or share a thought below. It helps other curious minds find a place to rest. But for now, get comfortable. Let your eyes grow heavy. Let's begin. For centuries, we believed our solar system was the only one of its kind. It was a reasonable assumption, born from the quiet solitude of our vantage point. We looked out and saw only stars, burning steadily in the unbroken velvet of night. The idea of other worlds was a dream, a story we told ourselves to make the cosmos feel less empty, but without proof. It remained just that, a dream. Then, in the waning years of the 20th century, our instruments became sensitive enough to detect the faintest whispers of motion around distant suns. Suddenly, the universe was no longer a lonely expanse of scattered fires. It was teeming with neighbors, a grand, crowded neighborhood where nearly every star is a parent to its own silent, circling children. This realization did not just change astronomy, it fundamentally altered our sense of place, transforming us from a solitary anomaly into one member of a vast and ancient community of worlds. The first confirmed exoplanets were found in the most unexpected of places. They were not orbiting a gentle yellow sun like our own, but rather the dense, rapidly spinning remnants of a dead star known as a pulsar. This star, PSRB 1257+12, had long ago ended its life in a cataclysmic explosion, a supernova that should have scoured its vicinity clean of any solid bodies. Yet, there they were, mysterious undead worlds forged from the ashes of destruction, bathing in the eerie, rhythmic pulses of radiation from their skeletal host. Their discovery was a shock to the scientific community, a humbling reminder that the universe is far more resilient and creative than we often give it credit for. It taught us that planets could form and endure in the most extreme environments imaginable, clinging to existence long after their parent star has ceased to shine as it once did. To name these new worlds, astronomers adopted a humble and orderly convention. Rather than giving them grand mythological titles immediately, they are assigned the name of their parent star, followed by a simple lowercase letter. The first planet discovered in a system is given the letter B, the next C, and so on, while the star itself is implicitly A. It is a quiet, unassuming way to catalogue the infinite, a gentle nod to the order we try to find in the chaos of the cosmos. A planet like Kepler the 16b might sound clinical on paper, but that simple designation represents an entire world, perhaps with its own mountains, its own strange oceans, and its own sunsets that no human eye has ever seen. These modest names are placeholders for unimaginable grandeur, waiting patiently in stellar catalogues until we can learn their true nature. Most exoplanets are too distant to be seen directly, hidden by the blinding glare of their suns. Finding them is like trying to spot a firefly buzzing next to a massive, brilliant searchlight from thousands of miles away. Instead of looking for the planets themselves, astronomers often watch the stars, waiting with immense patience for a telltale sign. This method, known as the transit technique, relies on a fortuitous alignment of cosmic geometry. We wait for the planet to cross in front of its star from our perspective, a tiny silent eclipse that causes the star's light to dip by just a fraction of a percent. It is a gentle wink across the ocean of space, a fleeting shadow that betrays the presence of a world. By measuring this delicate dimming, we can determine the planet's size and how quickly it orbits, sketching the silhouette of a world we cannot yet see. Another way we find these hidden worlds is by watching the stars dance. A star does not sit perfectly still in space. It is tugged upon by the gravity of its orbiting planets, causing it to wobble ever so slightly back and forth. This gravitational dance is minuscule, a subtle shift in the star's light as it moves towards us and then away, known as the radial velocity method. It is as if the star is humming a quiet tune, the pitch rising and falling in a rhythm determined by the heavy worlds circling it. By listening closely to this stellar music, we can weigh the planets, determining their mass without ever seeing them directly. It is a testament to the interconnectedness of all things, where even a mighty star must bow slightly to the humble planets that accompany it through the galaxy. Among the first exoplanets discovered were giants that defied all our expectations. We call them hot Jupiters, massive gas giants similar in size to our own Jupiter, but orbiting perilously close to their stars, closer even than Mercury is to our Sun. In our own solar system, the giants reside in the cold, distant outer reaches, so finding them hugging their stars was a profound surprise. These behemoths race around their suns in a matter of days, their atmospheres superheated to thousands of degrees, likely howling with supersonic winds that never cease. They challenged our understanding of how planetary systems form, suggesting that planets might not stay where they are born. Instead, they may migrate inward over millions of years, drifting through the stellar disk until they find a fiery, stable rhythm near their parent star, forever changed by the journey. Not all planets are tethered to a star. Some are solitary wanderers, drifting alone through the eternal night between the stars. These are the rogue planets, worlds that were likely ejected from their original solar systems during the chaotic early days of formation, flung out by the gravitational tantrums of larger siblings. They travel untethered, with no sun to warm them, no years to mark time, and no days to break the endless darkness. Yet they are not necessarily dead worlds. They may still have molten cores that provide internal heat, perhaps even sustaining strange, frozen oceans beneath thick layers of ice. They are the silent nomads of the galaxy, pursuing their own lonely, majestic paths through the void, free from the gravitational commands of any sun. There is a class of planet that might be more precious than we could ever imagine. Orbiting the star 55 Cancri, A is a world that is twice the size of Earth, but 8 times as massive, incredibly dense and superheated. Because this system is rich in carbon, some scientists have theorized that extreme pressures and temperatures on this planet could have forged a significant portion of its mass into diamond. It might be a world where the bedrock is made of crystalline jewels, where the very geology glitters with a brilliance unseen on Earth. While it is a place entirely hostile to life as we know it, a hellscape of unimaginable heat, it exists as a dazzling reminder of the universes to forge beauty in the most extreme crucibles. It spins in the dark, a diamond weighing more than our entire world, a hidden treasure chest locked away by distance and fire. We are constantly searching for worlds that sit in the Goldilocks zone. This is the habitable zone, that slender, precious ring of space around a star where temperatures are neither too hot nor too cold, but just right for liquid water to exist on a planet's surface. It is a delicate balance, different for every star. For a blazing, massive blue star, the zone is far out in the cold reaches, while for a dim, cool red dwarf, it hugs the star tightly. Finding a planet in this zone does not guarantee life. Mars and Venus are on the very edges of our own sun's habitable zone, but it is where the potential begins. It is the cosmic shoreline where the waves of life as we know it might just be able to find a foothold, a temperate oasis in the vast, inhospitable desert of space. One of the most captivating systems we have found is known as TRA-PPI ST1. Located a mere 40 light-years away, it is a tiny, ultra-cool red dwarf star that hosts an incredible family of 7 Earth-sized planets. What makes this system so mesmerizing is how closely packed these worlds are. They orbit in tight formation, closer to their star than Mercury is to our Sun. If you were to stand on the surface of one of these worlds, the others would appear prominently in the sky, not just as bright stars, but as full, visible disks, perhaps large enough to see geological features with the naked eye. It is a crowded, intimate family of worlds, dancing together in a complex gravitational rhythm, a compact solar system that looks like nothing we have here, yet teems with the potential for deep, diverse mysteries. Our nearest exoplanetary neighbor is just next door, cosmically speaking. Orbiting Proxima Centauri, the closest star to our own Sun, lies a world called Proxima b. It is only slightly more massive than Earth and sits comfortably within its star's habitable zone, a tantalizing destination that has captured the imagination of dreamers and scientists alike. Though it is only 4 light-years away, that distance is still an immense chasm that would take our fastest current spacecraft thousands of years to cross. It sits there, just beyond our reach, a silent siren calling to us across the void. Astronomers can point their telescopes toward its faint red star in the southern sky, a constant reminder that another potentially rocky world is right there, waiting for the day we finally learn to bridge the gap between the stars. Some worlds may be entirely covered by boundless global oceans. Unlike Earth, where continents break up the vast expanse of blue, these water worlds would have no dry land at all. They might be larger than our planet, with oceans thousands of miles deep, far deeper than the thin skin of water that covers our own world. At those unimaginable depths, the pressure would be so intense that water might be crushed into strange, exotic forms of ice that remain solid even at the high temperatures, forming a bizarre seafloor of hot ice mantle. These planets would be endless expanses of rolling waves under alien suns, perhaps home to deep-sea leviathans that never need to know the concept of a shore. living their entire existence in a three-dimensional aquatic universe. Much of what we know about these worlds comes from a single legendary watcher. The Kepler Space Telescope was launched with a singular, ambitious mission: to stare unblinkingly at one patch of sky, watching over 150,000 stars simultaneously for years on end. It was a patient sentinel, drifting in the silence of space, waiting for those tiny telltale dips in light that signal a planet's transit. Before Kepler, we knew of only a handful of exoplanets. By the time it finished its mission, it had opened the floodgates, revealing thousands of candidates and confirming that our galaxy is packed with worlds. It taught us that small planets are common, that nature loves diversity, and that if you just look long enough at the darkness, you will eventually see the shadows of new worlds passing by. There is a type of planet very common in the galaxy that our solar system completely lacks. We call them super-Earths, worlds that are larger than our Earth, but smaller than giants like Neptune. They represent a missing link in our own planetary family, a middle ground that nature seems to favor elsewhere. We do not yet know if they are merely scaled-up versions of our own rocky home, with massive continents and crushing gravity, or if they are mini Neptunes, shrouded in thick, suffocating envelopes of gas, with no solid surface to stand upon. They are a tantalizing mystery, a class of world that might be the most common type in the universe, yet we have no local example to study. They remind us that our home system is just one roll of the cosmic dice, and not necessarily the standard template. Many exoplanets are locked in an eternal staring contest with their stars. This phenomenon is called tidal locking. Just as our moon always shows the same face to Earth, these planets rotate exactly once every time they orbit their star, meaning one side is perpetually bathed in searing daylight, while the other is frozen in unending night. There is no sunrise or sunset on these worlds, only a fixed sun in the sky that never moves. Between the burning day side and the frozen night side lies the terminator zone, a thin ring of perpetual twilight where temperatures might be mild enough for life to exist. It would be a strange existence, living in a land of eternal dusk, with a blazing, terrifying desert on one side and a kingdom of everlasting ice on the other. On some of these distant worlds, the weather is more fantastic than any science fiction. We have found evidence of planets where the atmosphere is so hot that rock vaporizes during the day, only to condense and fall as rain made of molten pebbles on the cooler night side. There is a vivid blue gas giant, where it likely rains molten glass, blowing sideways in winds screaming at thousands of miles an hour. These are not gentle spring showers. They are ferocious, majestic displays of elemental power, where the very air is thick with vaporized metals and minerals. It is a reminder that the familiar, life-giving water cycle of Earth is a rare and gentle luxury compared to the violent, exotic chemistries that churn in the skies of more alien worlds.
Not all planets follow the neat, circular paths we are used to.
In our solar system, the planets have mostly settled into calm, nearly perfect circles around the Sun. But many exoplanets have highly elliptical orbits, swinging wildly close to their stars before soaring far out into the cold, dark reaches of their systems. For any hypothetical inhabitants, the seasons would be extreme and long-lasting. A short, blistering summer, when the star fills the sky, might be followed by years of deep, frozen winter as the planet retreats to the outer edges of its orbit. These eccentric planets show us that solar systems can be dynamic, perhaps even chaotic places where worlds are still finding their rhythm in the complex gravitational dance of their siblings. The colors of these worlds would likely stun human eyes. We are used to the blue marble of Earth, the rusty red of Mars, and the beige bands of Jupiter. But exoplanets might be vastly different. A planet orbiting a cooler, redder star might have plants that are black or deep purple to absorb as much of the dim light as possible. A hot Jupiter might be a deep, smoky indigo due to silicate clouds in its high atmosphere, while another might be incredibly dark, darker than fresh asphalt, absorbing almost all the starlight that hits it. We can only imagine the palettes that paint these distant landscapes, colors born from alien chemistries and strange suns, creating vistas of breathtaking, unfamiliar beauty waiting in the dark. The sheer age of some exoplanetary systems is humbling. We have found planets orbiting stars that are nearly as old as the universe itself, systems that formed more than 11 billion years ago, long before our own sun even existed as a cloud of dust. These ancient worlds have been circling their stars for eons, witnessing the slow evolution of the galaxy around them. Civilizations could have risen and faded into dust on their surfaces billions of years before humanity took its first breath. They are the elders of the Milky Way, silent time capsules that have endured through nearly the entire history of time, carrying secrets of the early universe that we are only just beginning to wonder about. Despite finding thousands of them, the distances to these worlds remain vast beyond true comprehension. We talk about light years easily, but a single light year is nearly 6 trillion miles. To travel to even the closest exoplanet with our current technology would take tens of thousands of years, a journey spanning hundreds of human generations living and dying in the void. We cannot touch them. We can only watch them from afar, catching their faint signals as they wash over our planet. They remain, for now, tantalizingly out of reach. Like distant islands seen from the shore of a vast ocean, we have not yet learned to sail. But even from this distance, they offer a profound comfort. They tell us that while we may be distant, we are certainly not alone in the grand expanse. Some stars are not content with hosting just a few worlds. They nurture vast families. We have discovered systems that rival our own in complexity, like Kepler-90, which ties with our solar system for having the highest number of known planets, 8. It is a crowded, compact version of our own home, with all of its 8 planets squeezed within a distance similar to Earth's orbit around the Sun. It shows us that planetary formation is a robust and prolific process, capable of packing many worlds into relatively small spaces. Looking at Kepler-90 is like looking into a funhouse mirror version of our own system, a reminder that the architecture we know is just one of countless possible blueprints for building a family of worlds. The search for exoplanetary moons, or exomoons, is the next great frontier. Just as Jupiter and Saturn host dozens of moons, it is almost certain that many gas giant exoplanets have their own retinues of smaller rocky satellites. These moons might even be more habitable than the giant planets they orbit, perhaps warmed by tidal forces or protected by the giant's magnetic field. Finding them is incredibly difficult, pushing our current technology to its absolute breaking point, as their signals are vanishingly small, lost in the noise of their parent planet and star. But the first tentative candidates have already been spotted, hinting at a universe where moons might be just as common, and perhaps just as welcoming to life as the planets themselves. There are worlds that are slowly evaporating before our very eyes. Some planets orbit so close to their stars that the intense heat and radiation are actively stripping away their atmospheres. They leave behind vast, comet-like tails of gas trailing millions of miles into space, a visible sign of their slow dissolution. It is a gentle, drawn-out cosmic death, as a majestic gas giant is slowly whittled down over eons, perhaps eventually leaving behind only its bare, scorched rocky core. These evaporating worlds are a poignant reminder of the immense power of stars, capable of unmaking the very worlds they help to create, returning their material back to the cosmic void. We have found planets in star systems with more than one sun. Like the fictional world of Tatooine, there are planets that orbit two stars at once, known as circumbinary planets. Standing on such a world, you would see two suns in the sky, perhaps of different colors and sizes, engaging in an endless, intricate dance. Shadows would be double, sunsets would be complex and beautiful displays of light, and the very concept of day and night would be governed by the complex rhythm of two stars. These systems were once thought to be unstable, too chaotic for planets to survive, but nature has proven us wrong again, showing that life's potential stages are far more varied than we ever dreamed. The atmospheres of these distant worlds can be analyzed from trillions of miles away. When a planet transits in front of its star, some of the starlight filters through the thin rim of its atmosphere on its way to Earth. By carefully analyzing this filtered light, we can identify the chemical fingerprints of gases present in that distant air. We have already detected water vapor, methane, carbon dioxide, and even more exotic elements like titanium oxide in the skies of alien worlds. It is like sniffing the air of a planet from across the galaxy, a technique that might one day allow us to detect the telltale chemical signatures of life itself, breathing quietly on a distant sphere. Not all planetary systems are flat like ours. Our solar system's planets all orbit roughly in the same flat plane, like marbles rolling on a dinner plate. But we have found systems that are wildly misaligned, where planet orbits are tilted at steep angles to one another, or even orbiting over the star's poles rather than its equator. Some planets even orbit backward, moving in the opposite direction to their star's rotation. These chaotic architectures hint at violent pasts, perhaps ancient gravitational encounters that scattered the planets like billiard balls, leaving them in these strange, tilted paths as lasting monuments to a turbulent history. There is a planet that is so dark, it eats almost all light that touches it. Tries 2b is a gas giant that reflects less than 1% of the light that hits it, making it darker than coal or black acrylic paint. It is a true dark world, a looming shadow against the brilliance of its parent star. The reasons for this extreme darkness are still a mystery. Perhaps its atmosphere is filled with light-absorbing chemicals that we haven't yet identified. It drifts through space like a silent, pitch-black ghost. A world that prefers to remain hidden, absorbing the energy of its star without ever giving any of it back to the universe in the form of visible reflection. We may have already found planets that are drifting through the galaxy's habitable era. Just as there is a Goldilocks zone in space, there might be a Goldilocks time in the history of the universe. Early on, the cosmos might have been too hot and chaotic, while in the far future, stars will burn out and the universe will grow cold. We are living in the peak era for star formation and planetary stability. a bountiful cosmic summer. The exoplanets we see now are the children of this golden age, existing in a time when the universe is most hospitable to complexity and perhaps to life. We are lucky to be awake and aware during this vibrant chapter of cosmic history. Some planets might be covered in global oceans of lava. These are rocky worlds that orbit so close to their stars that their surfaces are perpetually molten. Kepler 10b and Corot 7b are prime examples, places where the ocean is made of liquid rock and the land might just be cooler, floating rafts of solid crust. The temperatures on their day sides are hot enough to melt iron, creating a hellish landscape that is constantly resurfacing itself. While hostile to life, these lava worlds offer a glimpse into the violent, incandescent youth of all rocky planets, including Earth, which once shone just as brightly with the heat of its own formation. The great silence of these billions of worlds is a profound mystery. With so many planets, many of them potentially habitable, we are faced with the Fermi paradox. If life is common, where is everyone? We have listened for radio signals and looked for signs of mighty alien engineering projects, but so far the cosmos remains quiet. This silence is not necessarily empty. It might just mean that civilizations are rare or fleeting, or perhaps they are simply too far away in both space and time for us to have crossed paths yet. It makes our own existence here on Earth feel all the more precious. A rare and beautiful song in a mostly quiet, vast auditorium. Future telescopes promise to revolutionize our view of these worlds. We are on the cusp of a new era with instruments like the James Webb Space Telescope and the upcoming extremely large telescopes on the ground. These mighty eyes will be able to peer directly into the atmospheres of smaller, Earth-like worlds, looking for the specific combinations of gases that could only be produced by life. We might soon be able to see not just the shadows of these worlds, but their weather patterns, perhaps even catch glints of their oceans or the seasonal changes of alien vegetation. We are slowly moving from simply counting these worlds to truly understanding them as places. Some planets are incredibly puffy and light. We have found gas giants that are almost as big as Jupiter, but have incredibly low densities, some less dense than styrofoam or cork. If you could find a cosmic bathtub big enough, these planets would float easily on the water. They are likely puffed up by the intense heat of their nearby stars, their atmospheres expanded into vast, tenuous envelopes of gas. They challenge our definitions of what a planet can be, blurring the line between a solid world and a coherent cloud, existing as ghostly, almost ethereal giants drifting near their blazing suns. Planets can exist around dead stars, known as white dwarfs. When a sun-like star dies, it swells into a red giant, often consuming its inner planets, before collapsing into a small, dense white dwarf. Remarkably, some planets survive this chaotic process, or perhaps new ones form from the debris left behind. We have seen signs of rocky material raining down onto white dwarfs, the likely remains of shredded planets. But we have also found intact giant planets still orbiting these stellar corpses. It shows that planetary systems can have a second life, a quiet, cold afterlife that continues long after the main sequence of their star has ended. The sheer variety of planetary systems suggests there is no standard model. For a long time we thought our solar system, small rocky planets on the inside, big gas giants on the outside, was the norm. But we have found systems that are the exact opposite, or systems with no gas giants at all, or systems with only gas giants. It seems the universe is a master improviser, capable of building planetary systems from whatever materials are at hand, in whatever chaotic arrangement gravity dictates. There is no rigid blueprint, only endless creative variations on a theme, each one a unique masterpiece of cosmic engineering. We are beginning to find planets around very young stars, still in the process of forming. By looking at the swirling disks of dust and gas around newborn stars, we can see the telltale gaps and spirals carved out by infant planets coalescing from the debris. These are baby pictures of solar systems, showing us the messy, violent, and beautiful process of world building in action. Watching these systems gives us a time-lapse view of our own history, allowing us to witness the chaotic birth pangs that eventually settle down to create the orderly, stable home we enjoy today. Some exoplanets might have rings that dwarf Saturn's. We have seen evidence of a planet, J1407b, which appears to have a ring system nearly 200 times larger than Saturn's. If this planet were placed where Saturn is in our sky, its rings would be larger than the full moon and clearly visible even during the day. It would be a spectacular, dominant feature of the night sky, a colossal celestial jewel. These super rings might be the raw material for a future family of many moons, a massive disk of potential waiting to coalesce into solid worlds. The concept of a super habitable world is tantalizing. Scientists have proposed that Earth might not be the absolute best possible world for life. There might be planets that are even better suited, perhaps slightly larger with more surface area, orbiting older, more stable stars that give life more time to evolve, or with thicker atmospheres that provide better protection and more uniform warmth. These super habitable worlds could be paradises teeming with life far richer and more diverse than our own, true gardens of the galaxy that make our own vibrant world look modest by comparison. We have discovered planets in the midst of star clusters. Imagine living on a world inside a dense globular cluster surrounded by hundreds of thousands of stars. The night sky would be unbelievably brilliant, packed with stars far brighter than Sirius or Venus appears to us, perhaps casting enough light to read by even at midnight. It would be a sky perpetually filled with glittering jewels, a view so overwhelming and majestic that it might fundamentally change how any inhabitants view the universe, not as a dark void with scattered points of light, but as a blindingly bright, crowded city of suns. Every new discovery refines our understanding of our own home. By studying the extremes of exoplanets, the hot Jupiters, the lava worlds, the frozen ice giants, we better understand the delicate balances that make Earth possible. We learn to appreciate the specific, fortunate circumstances that allowed liquid water to persist here for billions of years, creating the stable cradle for us to evolve. Exoplanet science is not just about looking out there. It is a mirror that reflects back upon us, helping us to truly see and value the rare, fragile beauty of our own blue oasis in the endless dark. Ultimately, the hunt for exoplanets is a hunt for context. We are searching for where we fit in the grand scheme of things. Are we a common, inevitable outcome of cosmic chemistry? Or are we an incredibly rare, lucky accident? Every new world we find is another data point, another piece of the puzzle. We are slowly building a map of our galactic neighborhood, turning the unknown here be dragons regions of the star charts into known, charted territories. It is a long, slow journey of discovery, but one that is fundamentally changing our relationship with the sky, transforming it from a distant painting into a vast, waiting frontier. There is a world where the very air turns to iron when night falls. On the distant exoplanet WASP-76b, the difference between day and night is not just a matter of light, but of fundamental state. The day side, forever facing its searing star, is hot enough to vaporize iron, turning heavy metal into tenuous clouds that drift through the upper atmosphere. Observations suggest that as powerful winds carry these metallic clouds toward the cooler, eternal night side, the iron condenses, falling from the sky as a heavy, molten rain. It is a weather system of unimaginable power and strange majesty, where the basic elements of construction on Earth become the fleeting weather of an alien sky. It reminds us that familiar is just a local concept, and that somewhere out there, even iron can be as ephemeral as a gentle morning mist. We sometimes find worlds by using the fabric of space itself as a lens. This technique, known as gravitational microlensing, relies on a rare cosmic coincidence where a foreground star passes precisely in front of a distant background star. The gravity of the nearest star bends and magnifies the distant light, acting like a giant natural telescope glass. If a planet happens to be orbiting that foreground star, its own small gravity adds a tiny extra spike to the magnification, a fleeting signature that reveals its presence. It is a method that requires immense patience, waiting for the universe to perfectly align itself for just a few days or weeks. It allows us to find cold, distant worlds that would otherwise remain forever invisible, hidden in the deep dark, revealed only by a momentary trick of warped light. Just as there are habitable zones around stars, there may be a habitable zone for the entire galaxy. The center of our Milky Way is a chaotic, crowded place, packed with intense radiation from giant stars and a supermassive black hole, likely too dangerous for complex life to stabilize. Conversely, the very outer edges of the galaxy might lack the heavy elements needed to build rocky planets, being composed mostly of simple hydrogen and helium. We reside in the galactic suburbs, a calm Goldilocks ring, about halfway out from the center, where conditions are stable and the materials for life are plentiful. It suggests that our location in the greater galactic city is just as fortunate as our location near our sun, a quiet, safe neighborhood in a sprawling metropolis of stars. Water, the precious elixir of life on Earth, appears to be surprisingly common across the cosmos. We have detected the spectral signature of water vapor in the atmospheres of dozens of exoplanets, from scorching hot Jupiters to smaller, cooler worlds. It seems that the universe is quite efficient at creating this simple, vital molecule, scattering it like seeds across the star systems. While finding water vapor doesn't always mean there are liquid oceans, it might just be steam in a hot atmosphere. Its widespread presence is deeply encouraging. It means the primary ingredient for life, as we understand it, is not a rare magical substance restricted to Earth, but a standard component of the cosmic recipe, waiting on countless worlds for the right conditions to settle into life-giving seas. The plants on other worlds might not be green. On Earth, plants appear green because chlorophyll is efficient at using the abundant yellow light from our sun. But a planet orbiting a cooler, dimmer red dwarf star might be covered in vegetation that is black, maroon, or deep purple, evolved to absorb every possible photon of the scarce light. Conversely, a world around a brighter, hotter star might have silvery or highly reflective plants to protect themselves from too much intense radiation. We can imagine forests of towering, ebony trees under a crimson sun, or glittering, mirrored meadows under a blazing blue sky. Life, if it exists elsewhere, will have painted its home with its own unique palette, adapted perfectly to the light of its own home star. Some worlds are so ancient they challenge our understanding of when planets first formed. Observations once suggested that a planet orbited a nearby star called Captain's Star, with an age of over 11 billion years, formed when the Milky Way was just an infant galaxy. Whether that particular world truly exists is still debated, but planets this ancient could have been circling their stars for more than twice the current age of our own Earth, silent witnesses to almost the entire history of the cosmos. If any life ever arose on such a world, it could have come and gone billions of years before our own sun even ignited. These ancient sentinels remind us that we are the new arrivals on the galactic stage, and that vast, untold histories might have played out in the deep reaches of time long before humanity began to dream. The line between a giant planet and a small star is blurrier than we once thought. There exists a class of celestial objects known as brown dwarfs, sometimes poetically called failed stars. They are far more massive than Jupiter, yet not quite massive enough to ignite the sustained nuclear fusion that makes a true star shine. They sit in the twilight zone between planet and star, glowing dimly with their own internal heat, slowly cooling over billions of years. Some of them even have their own planets orbiting them, blurring the definitions even further. They are a reminder that nature does not strictly adhere to the neat categories we create. It exists in a continuous, beautiful spectrum of size and energy. The search for these worlds has become a shared human endeavor. Through projects like Planet Hunters, vast amounts of data from space telescopes have been made available to the public. Ordinary people, sitting at their home computers, have scanned light curves with their own human eyes, spotting the subtle dips that automated computer algorithms sometimes miss. It is a beautiful democratization of science, where a retired teacher or a curious student might be the very first human being to realize that a specific distant star is not alone. It connects us all to the cosmos, proving that curiosity and patience are just as important tools as the most advanced supercomputers in the hunt for our cosmic neighbors. There is a theoretical type of world known affectionately as an eyeball planet. These would be tidally locked worlds, where one side always faces the star and the other always faces the dark. If such a planet had water, it might be frozen solid on the night side and boiled away on the day side. But right in the middle, at the point directly facing the star, there could be a stable, circular ocean of liquid water, resembling the iris and pupil of a giant eye staring back at its sun. It would be a world with a single, boundless sea in the center of a frozen desert, a strange and precarious oasis maintained by the delicate balance of extremes. The orbits of planets in compact systems often fall into a beautiful mathematical harmony. This is called orbital resonance. For example, for every 2 times one planet orbits, the next one out might orbit exactly once. In the TRAPPIST-1 system, the 7 planets are locked in a complex resonant chain, their gravitational tugs on each other keeping the whole system stable over billions of years. If you were to translate these orbital ratios into audio frequencies, they would form a harmonious musical chord. It is a literal music of the spheres, a grand, silent symphony played out by entire worlds over eons, held together by the invisible, rhythmic conducting of gravity. We have found planets with densities so low they seem almost impossible, known as super puffs or cotton candy planets. Worlds like Kepler-51b are almost as big as Jupiter, but have less than 1% of its mass. They are incredibly airy, likely composed almost entirely of hydrogen and helium atmospheres that have puffed up to enormous sizes. They are barely there, ghostly worlds that would float like dandelion seeds if placed in a cosmic ocean. They challenge our understanding of how atmospheres can hold together, appearing as fragile, tenuous bubbles of gas that somehow endure against the harsh environment of space, drifting serenely like clouds that have decided to become worlds. The arrangement of our own solar system may have been shaped by a grand migration. Theorists believe that Jupiter may have once drifted much closer to the Sun before moving back out to its current position, a maneuver known as the Grand Tack. Seeing the chaotic, varied arrangements of exoplanet systems has given huge support to this idea, showing that planets often migrate far from their birthplaces. It means our own stable, orderly home might be the result of a dramatic, ancient journey where mighty Jupiter cleared the path for the small, rocky Earth to eventually form in safety. We are likely the fortunate beneficiaries of a chaotic, primordial dance of giants that settled down long ago. Planets may be able to sweat out a second atmosphere if they lose their first one. Some rocky worlds that orbit close to their stars might have their original, primordial atmospheres stripped away by intense radiation. But if these worlds are geologically active, volcanoes can slowly release gases from deep within their molten interiors, wrapping the planet in a new secondary atmosphere over millions of years. It is a spectacular act of planetary rebirth, a world refusing to remain naked in the cold void, rebuilding its protective blanket through the sheer stubborn force of its own internal heat. It teaches us that planets are dynamic, resilient things, capable of healing themselves from the harsh stripping of their parent stars. We might one day be able to see exoplanets by their light echoes. Just as sound echoes off a canyon wall, light can echo off dust and gas in a star system. If a star flares brightly, that pulse of light will travel out, hit a planet, and reflect back to us with a delay. By precisely timing these light echoes, we could potentially map the continents and oceans of a world we cannot even see directly. It would be like using a flash camera across interstellar space, waiting years for the reflected flash to return, carrying with it a blurry, precious snapshot of an alien landscape hidden in the dark. Lonely rogue planets might occasionally find new homes. A planet ejected from its original system could drift for eons in the dark, only to eventually pass close enough to another star to be captured by its gravity. It would then settle into a new orbit, an adopted child in a strange new family of worlds. These captured planets might have very unusual orbits, perhaps moving backwards compared to the native planets, or tilted at extreme angles. They would be fascinating immigrants, carrying the geological history of a completely different star system, now warmed by a new sun they were never meant to know. The auroras on some exoplanets would be blindingly spectacular. On worlds with powerful magnetic fields, like super Jupiters, the interaction with stellar wind would create auroras 1,000,000 times brighter than the northern lights on Earth. These wouldn't just be gentle curtains of green and red. They would be global storms of ultraviolet and radio energy, lighting up the planet's poles with intense, crackling power. We can actually detect these worlds by listening for the radiostatic their mighty auroras generate, hearing the roar of their magnetic storms across the light years. It is a majestic display of unseen energy, crowning these distant giants with halos of invisible fire. A new class of potentially habitable worlds has recently been proposed. Hycean worlds. These are planets that are larger than Earth, covered entirely in deep, hot oceans, under thick atmospheres rich in hydrogen. While hotter and stranger than Earth, the immense depths of their oceans might be comfortable enough for simple life to thrive, protected from the intense atmospheric pressure above. They broaden our imagination of where life could be, suggesting it might not need an Earth twin at all, but could perhaps flourish in these warm, boundless, planet-wide seas under alien, hazy skies. As we confirm more worlds, we are slowly beginning to give them true names. While scientific designations like HD 209458b are necessary for catalogues, astronomers have begun officially naming certain prominent exoplanets after mythological figures from cultures around the world. We now have worlds named Dagon, Osiris, and Brahe. It is a deeply human impulse, the need to personalize the unknown, to bring these distant, abstract spheres into the fold of our shared stories and histories. It transforms them from cold data points into places with identity, acknowledging them as permanent fixtures in our growing map of reality. Some rocky worlds might not have a solid surface at all, but a misty transition. On Earth, there is a clear line where the air ends and the ocean or land begins. But on planets with incredibly thick, high-pressure atmospheres, something called a supercritical fluid might exist. The immense pressure would force the gas of the atmosphere to become as dense as a liquid without ever actually condensing into a distinct surface. Descending onto such a world, you wouldn't splash down or land. The air would just get thicker and thicker until you were swimming in a hot, dense soup of fluid rock or water. It would be a world without a shore, a seamless, terrifyingly beautiful gradient from sky to interior. The most staggering fact of all might just be the numbers. Current estimates suggest there are at least as many planets in our Milky Way as there are stars. That means hundreds of billions of worlds in our galaxy alone. If you were to count one exoplanet every second, it would take you more than 3,000 years just to count the worlds in our own galactic neighborhood. And beyond the Milky Way lie trillions of other galaxies, each with their own untold billions of planets. The sheer scale of this reality is not meant to make us feel small. It is meant to make us feel surrounded, adrift in an ocean of worlds so vast that loneliness becomes a statistical impossibility. Gravity can sometimes shape entire worlds into strange, unrecognizable forms. We typically imagine planets as perfect spheres, like polished marbles. But some hot Jupiters orbit so close to their massive stars that the immense gravitational pull stretches them out. These planets, like WASP-12b, are not round. They're shaped like eggs, permanently distended with their pointed ends facing their star. They are worlds under immense constant tension, their very substance being pulled by tides thousands of times stronger than our moon exerts on Earth's oceans. It is a portrait of a world caught in an eternal cosmic tug-of-war, a shape that defies our expectations of planetary perfection, demonstrating the raw, sculpting power of gravity when acting at such terribly close range. There appears to be a mysterious gap in the sizes of planets we have found. Known as the Fulton Gap, astronomers have noticed a surprising scarcity of planets that are between 1.5 to 2 times the size of Earth. It seems nature prefers to make either smaller, rocky super-Earths or larger, gaseous mini-Neptunes, but very little in between. This might be a cosmic dividing line. Perhaps planets in this size range cannot hold on to their thick atmospheres and shrink down to rocky cores, Or perhaps they quickly gather too much gas and balloon up into giants. It is a silent boundary in the laws of planetary formation, a no man's land that helps us understand the distinct families that worlds naturally fall into. It is possible for two planets to share the exact same orbit. These are known as Trojan planets, or co-orbital worlds. Just as Jupiter has clusters of asteroids that lead and follow it in its orbit around the Sun, it is theoretically possible for fully formed planets to exist in these stable gravitational sweet spots. Imagine a sister world that is always exactly 60 degrees ahead of you in the sky, a constant, bright companion that you can never catch up to, and that never catches up to you. They would endlessly chase each other around their star, locked in a perfect, eternal celestial stalemate, forever sharing the same year but never meeting. Some worlds might be warm enough for life without ever seeing a sun. Rogue planets, drifting alone in the dark, might not all be frozen solid. If a rogue planet is large enough and has a thick enough atmosphere of dense hydrogen, it could trap the heat generated from its own internal formation effectively. Alternatively, it might have a large, close-orbiting moon. The tidal push and pull between the planet and its moon would generate friction inside both, keeping them warm through tidal heating long after they have left their parent star. These would be dark, warm worlds where life could huddle around geothermal vents, thriving entirely on the internal energy of their lonely planet, completely ignorant of the stars above them. We have found evidence of solar systems more complex than we ever imagined. While two suns might seem exotic, we have found a planet in a quadruple star system. The planet, PH1b, orbits a pair of stars, while another pair of stars orbits that entire central group further out. The sky on such a world would be a dazzling display of celestial mechanics, with 4 different suns rising and setting in complex patterns, perhaps meaning true darkness never really falls. It shows that nature can find stable, lasting harmonies, even in the most seemingly chaotic arrangements of multiple massive bodies, building intricate, whirling clockwork mechanisms out of pure starlight and gravity. Sometimes, a discovery turns out to be a beautiful phantom. For years, astronomers believed they had directly imaged a planet orbiting the bright star Fomalhaut. It was a tiny pinprick of light that seemed to move in an orbit over several years. However, later observations suggested the planet had vanished, fading away completely. It is now believed that what we saw was not a solid world, but a gigantic, expanding cloud of very fine dust produced by a massive collision between 2 icy asteroids. We had not watched a planet, but the ghostly aftermath of a cosmic cataclysm, a fleeting cloud of debris that briefly masqueraded as a world before dispersing back into the silence of the dust ring. If we could see with radio eyes, the sky would be full of beacons. We often look for worlds similar to Earth, but many gas giants likely have incredibly powerful magnetic fields. These fields would act like gigantic radio transmitters, broadcasting loud, coherent signals into the galaxy as they interact with the solar wind. If our eyes could see these radio wavelengths, the night sky wouldn't just be filled with stars. It would be dotted with furiously bright, pulsing beacons from thousands of invisible worlds. We are bathed in their silent songs every night, a grand, invisible chorus that our technology is only just beginning to tune into. The winds on these distant worlds are faster than anything on Earth. On some hot Jupiters, the temperature difference between the blistering day side and the frozen night side is so extreme that it drives supersonic winds. These global gales can reach speeds of over 5,000 miles per hour, 10 times faster than the most powerful jet aircraft. They are planetary-scale jet streams that continuously roar around the entire equator, desperately trying to distribute the star's intense heat. It is a weather system of unending raw power, a perpetual storm that scours the upper atmosphere, ensuring that even the quiet side of the planet is never truly still. Some planets might be covered in oceans of strange fuels. On Titan, a moon in our own solar system, there are lakes of liquid methane and ethane. It is highly likely that many cold exoplanets are similar, with entire hydrological cycles based not on water, but on liquid hydrocarbons. You might have methane rain falling onto hills of solid water ice, forming rivers of natural gas that flow into vast, calm petrol seas. These worlds would be frigid and alien, yet they might possess a strange, familiar beauty, with waves lapping on dark shores under hazy orange skies, proving that ocean does not always mean water. Red dwarf stars, the most common in the galaxy, might be the best cradles for long-term life. These small, dim stars burn their fuel incredibly slowly and will continue to shine steadily for trillions of years, far longer than the current age of the universe. Planets orbiting them have an almost eternal future ahead of them. While life on Earth has only a few billion years left before our sun gets too hot, civilizations on a red dwarf world could theoretically last nearly forever. They are the slow and steady tortoises of the cosmic race, offering their planets a stable, nearly unending hearth to huddle around, while the rest of the bright, massive stars in the galaxy burn themselves out. We are beginning to look for more than just biological life. We are looking for technosignatures. This is the search for signs of advanced technology that might be visible across the stars. It could be anything from the distinct pollutants in an industrial atmosphere to gigantic structures built around a star to harvest its energy. It is a search based on the hope that someone else out there has looked up, just as we have, and decided to build something grand enough to be seen by their neighbors. It transforms the hunt for exoplanets into a hunt for fellow builders, a quest to find a kindred intelligence that has left its mark on the very face of its star system. The very first exoplanet system ever found is also one of the strangest. Before we found planets around normal stars, we found them around a pulsar, the rapidly spinning, ultra-dense core of a dead star that emits beams of lethal radiation like a cosmic lighthouse. The planets there, Draugr, Poltergeist, and Phobeta, are bathed in this ceaseless rhythmic blasting. They are likely incredibly hostile places, zombie worlds orbiting a stellar corpse. Yet their existence is profoundly hopeful. It proves that planet building is so robust that it can happen even in the violent aftermath of a star's death, or that worlds can survive the very worst catastrophes the universe can throw at them. We are now capable of mapping the weather on worlds trillions of miles away. By continuously watching a planet as it rotates, we can see brighter and darker patches move into and out of view. This allows astronomers to create crude weather maps of these distant gas giants, spotting massive persistent storm systems similar to Jupiter's Great Red Spot. We have detected clouds that form and dissipate over days, and measured shifting wind patterns. It is an astonishing feat of long-distance meteorology, allowing us to watch the changing skies of alien worlds from the safety of our own quiet blue planet. Some rocky planets might be super habitable, better for life than Earth. We tend to think of Earth as the perfect standard, but some worlds might be even more ideal. A planet slightly larger than Earth would have more surface area for life to inhabit, and stronger gravity to hold a thicker, more protective atmosphere. If it orbited a star slightly cooler and longer lived than our Sun, complex life would have billions more years to evolve and diversify. These paradise worlds might be lush, vibrant, and incredibly diverse, making our own beautiful Earth look like a somewhat harsh and marginal outpost by comparison. There is a possibility that life could hop from world to world. This is the theory of panspermia. If a large asteroid hits a planet teeming with life, it can blast rocks containing hardy microbes out into space. These rocks could drift for millennia before landing on another planet in the same system, effectively infecting it with a life. In closely packed systems like TRAPPIST-1, this might be very common. It is a beautiful thought. A single family of worlds sharing not just gravity, but a shared biological heritage, with life drifting between them like seeds carried on the wind to neighboring islands. Future missions aim to take actual pictures of these worlds' surfaces. While currently impossible, astronomers dream of building enormous space telescopes or using fleets of small mirrors flying in formation to resolve the actual disks of Earth-like exoplanets. We might one day see the blue glint of an alien ocean, the green or purple smudge of a vast continent, or the white swirl of a hurricane on another world. It would be the ultimate portrait, finally turning these data points into true places, landscapes that we can look at and instantly recognize as another home in the dark. Our own radio broadcasts have already reached thousands of these systems. Humanity has been leaking radio and television signals into space for roughly a century. This creates a radio bubble about 200 light-years across, centered on Earth. Any civilization within this bubble with sensitive enough antennas could theoretically be listening to our early broadcasts right now. We have already announced ourselves to a small sphere of the galaxy. It is a quiet, unintentional greeting, a ripple of human culture expanding forever outward, carrying the sounds of our music, our news, and our lives to whatever ears might be waiting in the silence. The composition of some planets might be terrifyingly simple. We have found worlds that appear to be made almost entirely of heavy metals, likely the exposed cores of ancient gas giants whose outer layers were blasted away. Conversely, there might be worlds made almost entirely of water, with no rocky seabed at all, just endless ocean all the way down to a hot, compressed ice core. These single-ingredient worlds show us the extremes of planetary geology, places where the complex mixture of elements we enjoy on Earth is replaced by a frighteningly pure, monolithic simplicity. We have found a planet that appears to be pitch black. WASP 12b is not only egg-shaped, but it is also incredibly dark, absorbing almost 94% of the light that falls on it. It is darker than fresh asphalt. This is likely because it is so hot that standard clouds cannot form to reflect light, and its atmosphere is filled with atomic vapors that trap incoming radiation perfectly. It would appear to human eyes as a sinister, almost invisible hole in space, defined only by the faint, glowing red heat of its own agonizingly hot atmosphere. Even with all these discoveries, the most exciting fact is what we don't know. We have only searched a tiny, tiny fraction of our own galaxy. We have mostly found the easy planets, the big ones, the close ones. The vast majority of the galaxy's quiet, small, Earth-like worlds are still hidden from us, waiting for better technology to reveal them. We are like children who have just learned to walk, taking our first few stumbling steps into a vast, unexplored continent. The greatest surprises, the most beautiful worlds, and perhaps the most profound discoveries are all still waiting for us in the uncharted dark. Some worlds might experience rainfall made of precious gems. On the giant exoplanet HATP-7b, intense winds circulate clouds made of corundum, the mineral that forms rubies and sapphires. Because of the extreme temperature differences between the day and night sides, it is highly likely that as these clouds cool, they rain down liquid or perhaps even solid crystals of ruby and sapphire. It is a dazzling image, a storm of jewels falling through violent alien skies, a treasure trove that will never be collected, existing only as a spectacular, chaotic weather pattern on a world far beyond our reach. Gravity on some of these worlds would feel crushing to human explorers. On a massive super-Earth with a rocky surface, the gravitational pull could be several times stronger than what we are used to. Standing on such a world would feel like carrying 2 or 3 other people on your back every moment of every day. The native life forms there would likely be short, sturdy, and incredibly powerful to cope with the immense weight. It reminds us that our own graceful, upright posture is a luxury afforded to us by the relatively gentle gravity of our own home planet. Conversely, some small worlds would have gravity gentle enough to give us wings. On a small, rocky moon or a dwarf planet, the gravity might be so low that you could jump over a house with ease. If you were to attach simple wings to your arms, the thin atmosphere and weak gravity might allow you to fly just by flapping, soaring like a bird over alien canyons and craters. It would be a dreamlike existence, a place where the bonds of Earth are loosed, allowing for a freedom of movement that we can only experience in our deepest sleep. The seasons on some planets can last for human lifetimes. Planets with extremely wide orbits, taking centuries to circle their stars, would have seasons that last for decades. Imagine a winter that settles in for 50 years, a generation born that has never known warmth, hearing only stories from their grandparents of a time when the sun was high in the sky. Civilizations on such worlds would be shaped entirely by this slow, majestic turning of the climatic wheel, their entire cultures based on patience and the long, slow wait for the return of spring. We might one day find worlds that are eerily similar to our own deep past. Looking at younger star systems is like looking into a time machine. We might spot a planet that is just cooling its magma oceans, or one that is just beginning to develop a primitive, toxic atmosphere, exactly as Earth did 4 billion years ago. These echo-Earths allow us to watch our own biography being written in the stars, reminding us of the chaotic, violent, and miraculous journey our own world took to become the calm blue oasis it is today. There are likely planets that have been kicked completely out of their own galaxies. Just as planets can be ejected from solar systems, entire stars can be flung out of galaxies during collisions between these massive island universes. Any planets orbiting these exiled stars would find themselves in the truest void of all, intergalactic space. The night sky from such a world would be utterly terrifying in its emptiness, with no other stars visible to the naked eye, only the distant, faint smudges of entire galaxies millions of light years away. It would be the ultimate solitary existence, a lonely harbor of warmth in the deepest, darkest ocean of all. Silicon might replace carbon as the building block of life on some hotter worlds. On Earth, all life is based on carbon, but silicon is chemically very similar and can form complex chains as well, especially at higher temperatures. A silicon-based life form might look more like a living rock or a crystalline entity, moving with glacial slowness, thriving in temperatures that would instantly incinerate us. It challenges our very definition of what it means to be alive, suggesting that consciousness might be able to house itself in materials we consider cold and inert. Some planets might be ocean worlds in a different sense, oceans of molten metal. We know of small, incredibly dense worlds that orbit so fast they might be nothing more than the stripped metallic cores of former giants. These worlds could have surfaces of liquid iron or nickel, endless seas of white-hot metal that never freeze. The waves on these oceans would be slow, heavy, and incredibly destructive, crashing against shores of solid metal under a sky filled entirely by their nearby star. It is a forge world, a place of raw, elemental purity, where geology operates at melting points. The search for exoplanets teaches us patience on a generational scale. Some signals are so faint, or the orbits so long, that it takes decades of continuous observation to confirm a single world. Astronomers might spend their entire careers gathering data on a single star, only for the next generation to finally confirm the planet's existence. It is a majestic, slow-motion pursuit, a cathedral of science that we are building brick by brick, knowing we might not live to see the finished structure, but content in laying the foundation for those who will come after us. We are made of the same material as these distant worlds. Every atom in your body, the calcium in your bones, the iron in your blood, was forged in the hearts of ancient stars that exploded long before the Earth was born. The same stellar dust that clumped together to form these exotic exoplanets also clumped together to form you. In a very literal sense, when you look up at these worlds, you're looking at your distant cousins. We are all just different expressions of the same cosmic material, arranged in endless beautiful variations across the dark. Some planets might have rings that are not made of ice or rock, but of their own lost moons. If a moon gets too close to its parent planet, the difference in gravitational pull on its near and far side can tear it apart. This Roche limit means that some ring systems are actually the graveyard of ancient moons, pulverized into billions of shining fragments. Over time, these rings might clump back together to form new moons, a continuous, violent cycle of destruction and rebirth, playing out in silence above the cloud tops of giant worlds. There is a theoretical zone around black holes where planets could exist. While it sounds impossible, a sufficiently large and calm supermassive black hole could theoretically have stable orbits for planets far from its event horizon. These worlds would be heated not by a sun, but perhaps by the light of the background universe bent around the black hole, or by the intense energy of the accretion disk far away. It would be a twilight existence on the very edge of the ultimate abyss, a precarious foothold for reality in a place where space and time themselves are beginning to fray. The colors of the sunset on other worlds would be a breathtaking study in alien atmospheres. On Mars, sunsets are often blue. On a planet with a thick, hydrogen-rich atmosphere, the sunset might be a brilliant, shimmering crimson. On a world orbiting a blue giant star, the daylight might be harsh and blinding, but the sunset could soften into indescribable shades of violet and indigo. Each world paints its sky with its own unique brush, a daily masterpiece of light-scattering physics that no human eye has yet been privileged to see. We might already have been noticed by civilizations on these worlds. If we can see them transit their stars, they can theoretically see us transit ours. There is a specific strip of the sky from which Earth can be seen crossing in front of the Sun. Any watchers located on worlds in that strip could have detected our oxygen-rich atmosphere millions of years ago, realizing that the third planet of this yellow star is alive. We might be exoplanet Earth to alien astronomers right now, a fascinating data point in their own catalogues of distant, promising worlds. Deep under the ice of frozen exoplanets, complex ecosystems could thrive. Just as Antarctica has lakes sealed beneath miles of ice that teem with microbial life, alien ice worlds could host vast networks of life in their subglacial oceans. Protected from radiation by the ice shell and warmed by geothermal vents on the seafloor, these dark, sealed ecosystems could be incredibly rich and diverse. They would never know of the universe above the ice, living out their entire evolutionary history in a boundless, self-contained, pitch-black sea. The Voyager spacecraft carry a message to these distant worlds. Launched in the 1970s, the Voyager probes are carrying golden records filled with the sounds and images of Earth. Greetings in dozens of languages, the songs of whales, the music of Bach and Chuck Berry. They are messages in a bottle thrown into the longest, widest ocean of all. It is highly unlikely they will ever be found, but the act of sending them is a profound statement of hope, a declaration that we want to be known, that we want to reach out and touch the infinite, even if only with a fragile, golden whisper. Some worlds might be super puffs that are slowly losing their grip on reality. We have found planets with such incredibly low density that they are barely held together by their own gravity. They are more like coherent clouds than solid worlds, with atmospheres that fluff out thousands of miles into space, constantly leaking away. They exist on the very edge of being, fragile and ephemeral, reminding us that the line between a planet and a simple cloud of gas is sometimes just a matter of a little bit of gravity. The sheer silence of these empty spaces is a comforting thought. While the universe might be full of worlds, the spaces between them are unimaginably vast and quiet. All the noise, the hurry, and the stress of our daily lives are confined to this one tiny, thin layer of one small planet. Beyond our atmosphere, there is only a profound, endless, and peaceful silence that has reigned for billions of years. It is a vast reservoir of calm that wraps around our busy little world, a reminder that our struggles are small in the face of such majestic, quiet endurance. Ultimately, exoplanets have changed our fundamental philosophy. For most of human history, we believed we were the center of everything, a unique and special creation. Finding these billions of other worlds has completed the Copernican revolution, moving us from the center of the stage to being just one member of a vast, infinite audience. It is a humbling realization, but also a deeply connecting one. We are not lonely masters of a solitary void. We are participants in a grand, crowded, and beautiful cosmic community. As you drift off to sleep, remember that the galaxy is full of homes. Even if we never leave this one, it is enough to know they are there. Trillions of sunrises are happening right now over oceans of water, methane, and lava. Winds are blowing over silent crystal deserts, and strange moons are rising over clouds of ruby dust. The universe is not empty. It is overflowing with places, with possibilities, with quiet, majestic dramas playing out in the dark. You can rest easy knowing that the cosmos is far richer, far stranger, and far more wonderful than we ever dreamed. And so, our journey through the boundless world of exoplanets comes to a gentle close. We have traveled from blazing hot Jupiters to frozen rogue worlds drifting in the eternal dark, from planets made of diamond to worlds where rain falls as molten iron. We have seen that our galaxy is not a lonely scattering of stars, but a vibrant, crowded neighborhood, teeming with an infinite variety of worlds, each one a unique marble in the grand design. If you happen to still be awake, that's just fine. For the rest of the video, just let your mind grow quiet, breathe slowly, and drift along with the gentle music. But if your eyes are heavy, let the stories of these distant, silent worlds carry you gently into rest. Sleep well. Good night.